Good morning. Today we're going to be doing some electrical on the homestead. I always talk about how it's important to make things easier on yourself on the homestead because everything is reliant upon you. And so that's exactly what we're going to do. Now, the issue that we're solving today is to power up the chicken coop that is right over there. And the way we're going to do it easier today is to power it from the house, which is the meter base that is right there. And I'm going to be running an electrical wire all the way to this building right here. This used to be the old generator building that they used to store a generator in, shelter it from the elements, and now it's just being used for hay. And I found that the previous owners, they ran a cable from in behind the chicken coop over to the generator building over there, and they powered this chicken coop back here via generator. And to me that doesn't make sense. Why would you do that when you can run it off the house, off the solar system there, and not have to use fossil fuels? And what I did this past winter, because we didn't know how everything was laid out, I kind of found out that they ran a wire from this building here as well to the chicken coop. So what I did this past winter was run a extension cord from the box that I have in the old generator building there to the house. I ran a little receptacle and was able to power the heat lamps in the chicken coop. Now, what I'm gonna be doing is replacing that extension cord that I had running between the buildings with a tech cable that they had also running to my current generator building. So what we're gonna be doing today is running a cable out of there, or pulling it out. It's going into an octagon box there, and it goes underground here and all the way over to the building there where I currently have my generator. So I'm going to pull out that tech cable and then replace it over on that side. That way I can power it through my meter base, and then I'll show you the box that we make a connection to, and then the rest of it. And then that way I'll power the heat lamps and a couple other receptacles I have in here, which I'll show you coming up in the video. All right, so this is the junction box I was talking about that's in behind my chicken coop. Now this cable here, this one goes into the chicken coop and powers all the devices that I need powered. This cable here goes to the old generator building where I'm going to run my cable in between the house and that building. And this cable here is the one that currently runs out to my generator building. Now I'm going to open up this cover plate here with a number 2 or red Robbie screwdriver. And one thing to note is I'm doing this early morning while the chickens are still in their coop. Just that way I'm not in here disturbing them, or the rooster's not attacking me while I'm working. So if you do have work with chickens, make sure you do it when they're still in their coop and you're waiting for them to lay some eggs. All right, now that you open this box up, make sure you test the wires for safety right away. If you want, I'll leave a link in the description below for one of these pencil testers. They're great for sensing power. So you just want to test it. It's blinking, just letting you know that it's on. And if there was power in there, it would make a tone, and the light would stay on all the time. So this tells me that it is dead right now. Now what you want to do is completely separate all the wiring that you have in here. All right, now depending on what kind of octagon box you have in here, you can either spin on a lock nut. However, this one is a completely enclosed octagon box or weatherproof, and what you actually have to do is thread the connectors in and out, and then there is no lock nut on the bottom. So the best way to do this now is to take a pair of channel locks and undo your connector here. That way you're not trying to twist the whole wire out. So take off this connector here first so that you can slide the tech cable out, and then you can just spin out the connector itself. Somebody didn't want that one to come out. Alright, one thing I want to show you guys about tech cable is it's a great product. However, the only issue with it is the metal sheathing inside. Once it snaps, it becomes a problem because then it can start cutting your wires inside and then causing a short. So this cable, you can tell it's been driven on because it's flat in a couple spots. This was the worst cut that I've seen. However, when you look inside, there's still another rubber jacket before it gets to the wiring, which not all tech cable have. So now that I see that it has not penetrated this other rubber coating on it, I'm just gonna straighten it back out and then wrap it really good with electrical tape just to make it waterproof again. And then I'll be terminating it into the meter base. And what I'm going to also do is run a continuity test between the conductors to make sure that I have no shorts in between the wires themselves. So I'll show you that as well. One thing nice about tech cable is you'll know if you have a good seal or not, because there's a black gasket that you'll see tighten up and squeeze out of the connector here. And once you're at that point, you'll know you have a good tight seal on there and you won't have any liquid penetrating in there. Now we got to take off this gasket here, or this rubber piece off here to expose the wires, and then we'll pop it into the meter base after we shut the power off. One thing I like doing with tech cable is after you strip off this rubber piece here, is you leave a little nipple of rubber on there so that if you ever have any stress on the edge here, it's on the actual rubber and then not on the wire itself, and then together all these wires are a lot stronger than if they were all individually on there. So some electricians like to do that, some not. Teach their own, right? Alright, now before I put these wires into the meter base to make my connections, I'd want to run my continuity test to make sure that my wires, the conductors running the power, are not broken on the tech cable because it was run over and abused a little bit. I just want to confirm. And the way we're going to do this is this tech cable is a little bit different than what you'll see. Is sometimes they'll have a white wire in here, but this is from a three-phase system or commercial cable, and so they have the red, black, and blue, which is normal. Now what the previous owner did on the house is they used the black as a power and the blue as the neutral, or what would be your white wire. So I connected the wires on the other side there. And what I'm gonna do is get my meter, and you can do this with most meters, run a continuity test. Basically you need to take your your selector all the way to what looks like the an upside down U, and usually it'll have like a sound wave on there as well. And if you don't have that on your meter, I would recommend you stop this video and upgrade from Fisher Price right now, because if you don't have that, I would say you have a very, very cheap meter, which is a safety hazard to begin with. Make sure you get a good meter. So basically what we're gonna do now is I have it set on what my ohms is, and basically because it's connected on the other end, I will be making a full circuit, and if I hear that sound, that means that I have a full path of travel on my conductors. If I don't hear that sound, either my wires on the other end have come apart, or I have a break somewhere inside the cable itself. So let's check this out. So there you go. I have a sound coming from my meter. That's telling me that the wire is good. And now to confirm that I don't have it reversed or any way like that, I'm gonna go back to the other end of the cable, separate the blue and black wires from each other, and touch it again. At that time, I don't want a sound. If I don't have it, now I confirmed it twice just in the one go. And that way you're completely safe, and you have a peace of mind that you can move forward with your cable and you won't have any surprises. Alright, I've separated the wires on the other end. Now do your continuity test again, confirm the meter works, noise works, your meter works, and now we should have no noise. And success. We've confirmed the wire twice that it is in good condition, and now you can feel safe to put your wire into your box or your enclosure that you feel like. In my case, it'll be a meter base, but first let's go shut the power off. All right, I had to install a new receptacle in here. Because I was tying the wires into the main service box, or what you call the meter base, there was no overcurrent device, and if I was to hook it on to here with the old receptacle, I would not have any way to control the power in the chicken coop. So what I did was installed a AFCI, not a GFCI. They're two different things. You can look those up. So I installed an AFCI here. They look very similar to a GFI with the buttons. And so the AFCI here has a 20 amp pass-through like disconnect. So if I do have a short out there, it will pop the breaker or the reset on this receptacle, and then it will save anything that's in the chicken coop. So I installed a new AFCI here. I might leave a little description down at the bottom, the difference between an AFCI and a GFCI. So check out the description. I'm going to go into the chicken coop to make sure that the lights are working in there, and then I'll take you back to the meter base to show you exactly what I did with the wiring. All right. Light is working. The only thing I have to go check is the receptacles that are in there, but I figured all the power's got to go through all the receptacles in the coops, and if it's getting to this light, they should be good, and that's where I plug in my heat lamps. Let's go check out that meter base, and I'll just give you a quick little notes of things that I've noticed that were wrong in there, and how I hooked it up as well. So we'll check that up and wrap this video up. All right, we're here at the meter base now, and this is what you would have in the city as well. However, you would actually have your meter in there, and being that we're off grid and not on the city, we don't have a meter in here. The previous owner, he put in copper bars in there just to get the power going, which is okay. There's nothing wrong with that. The one thing I did notice is I have this cable that's coming in on the left. These wires are probably about a number 10, which are only good for 30 amps. And that's what's coming from the solar charger, which is on a breaker for 250 amps. So if you ever had anything higher than 30 amps on here, it wouldn't trip. the breaker itself. However, these wires, they would get extremely warm if I had anything else on them, and the insulation could melt and causing a short. So that's one thing I did notice, because if you look on the bottom side of this meter base, the wires are a lot bigger there, and those are meant for 100 amp services, which would be a number 3, I believe. And that's what they use there. So that's correct there, and the number 10s on there are incorrect. However, we're not running a lot of power in here, so I'm not really that concerned. A stove, for instance, is 40 amps. That's 100% all elements on, including the oven. So we don't have electric stoves in here. We don't have an electric dryer, so we don't have any big loads that we have to be concerned about. Now, what I did was I took this cable that I put into the other generator building, brought that in here. This red wire here that I have, I just capped it off and left it in there, and didn't connect it to anything because there's no point in connecting it. If I was to connect it, it'd be to the other side of the meter base, and that would be giving me 240 out to that receptacle, and I only need 120. So what I did was I went up the neutral in here that they already had going on with the panel. And what I did is I took my black wire and hooked it up to just the one side of the meter base itself, and that would be on the supply side. And now you can understand why I installed the AFCI in the little generator building there, because between this point and the generator building, I have no way to shut this the power off to the chicken coop unless I went and shut off the whole house itself, which is kind of a stupid idea and not the greatest. So I just tossed that AFCI in there just to give me a way I can shut it off, and now I also have a receptacle if I needed it out in the property anyway, or anywhere. Anyways, hopefully you got some info on that. If you got any questions in regarding the tech cable or connectors or electrical in any way, leave a comment down in the comment section and I'll get back to you. Until next time, you guys take care.